Welcome to the unit of energy. In this unit, we will be discussing the curriculum of New York State Regents Chemistry High School course. And so in this unit, I'm talking really about three main types of energy. Two of them are on the screen at the moment, kinetic energy and potential energy. In chemistry, these two types of energy relate back to the particles within them. And keeping it very simply, kinetic energy is a measurement of the speed of a particle. So the faster a particle moves, the faster it's traveling, the more kinetic energy it's going to have. A simplified way to look at the potential energy of any particle is to talk about the distance between them. And this measures potential energy in a simplified way. And so when we look at it, it's pretty simple to realize that solids, anything that's a solid, has the least potential energy because the distance between solid particles are small because they're tightly packed together. Whereas a gas will typically end up having the most potential energy because the distances between gas particles are greatest. So those are just two simplified versions that you're going to keep hearing about over and over and over again. In other classes, you maybe have talked about a picture like this, where anytime the biker or the roller coaster is going up or down the coaster or the hill, the kinetic energy is changing. And again, it makes a lot of sense, and it parallels very well because there's speed happening. Whereas the potential energy is located at the top of the hill, and only at the top of the hill. And that has to do with the fact that this biker has a distance off of the ground. So maybe you see the parallels, maybe not. And some other types of energy that are discussed, electromagnetic, thermal energy, heat energy, electrical energy. Chemical energy we talked about during bonding. Spent a lot of time talking about how the bonds of a molecule contain chemical energy. And nuclear energy, which we will get to later on down the road, units from now. So those would be, an overview. We'll specifically talk more right now about heat energy. And so this is the total energy that's produced by the molecular motion. So it kind of plays into the same type of energy as kinetic, but it's total, it's overall, it's everything included. Now, thermal energy or heat energy flows. One thing I always talk about is how there's really no such thing as cold. Cold is just an absence of heat, or it's less heat than something else. And so what that means is whenever two objects come into contact with one another, one doesn't gain cold, one just loses heat. And that heat flow always has to be from the area of high to low. Right? So heat energy always transfers from high to low. Or as I like to say sometimes, heat energy always transfers hot to not. And this lets us know that, if I have a, 80 degrees Celsius water, and I throw in a -5 degree Celsius ice cube, what happens here is the thermal energy goes from the water into the ice cube. That is the heat transfer that would occur. And this would cause the water's temperature to drop slightly. Obviously, the ice cube would reach 0 degrees, and then it would eventually melt. And so this is this heat transfer. Energy always goes from higher energies to lower energies. And another example is just like this. Completely ambiguous. Object A is 40 degrees. Object B is 80 degrees. They're placed in contact with one another. How does the heat flow? It flows from object B, the hot thing, to object A. Hot to not. There's one more section that we want to cover in this video, so we'll go into that now. At any time, pause the video, replay it, process it. But 2 new words that we're going to discuss are exothermic and endothermic. These words describe heat flow. Okay, they are describing the flow of heat because heat is either going in or heat is coming out. Every heat transfer has some exothermic part of it and some endothermic part of it. So, exothermic described as heat is released. We in the chemistry world, we're not great with the English language, at least I'm not. And when I see exo, I think exit, right? Exo, exit, they start the same, they mean the same thing. When you exit something, you're leaving. When you have exothermic, heat is the specific thing that is leaving. Now, when if you think about it this way too, when heat is being released, we would have to imagine that temperature of that substance would have to be decreasing. Right? The temperature has to decrease if heat is released. If you spontaneously started losing heat, you would get cold, right? Because you would have less heat. And so the same thing goes with phase changes. If water starts to lose heat and lose heat and lose heat, eventually the particles are going to slow down. They're going to have less kinetic energy. They're going to get closer together. They're going to get less potential energy. And all of that losing of energy would freeze the water. So exothermic phase changes always deal with temperatures decreasing and particles just losing their energy, both kinetic and potential. And for endothermic, again, English, endo, enter, they're very similar. Well, what happens when heat goes into things? Well, when heat goes in, temperature typically goes up, right? The temperature rises. Particles have more kinetic energy. They move faster. Particles get so much potential energy that when they're moving so fast and moving so fast and moving so fast, they eventually break apart from one another. They change phases. They get more potential energy, greater distances, right? Great distance between the molecules versus this distance. And this would happen in melting or boiling or sublimation. A substance just gains energy and then it turns it into potential energy. It turns it into speed of the molecules. Temperature goes up. And so these are the 3 introductory parts of our energy unit. Hope you enjoyed the video and, like it, subscribe to the channel. Check out some of the other videos on here. There's lots and lots of mind-melting content. Great. Catch you in the next video.